Okay, so this is a social media post generator using Langchain, GPT-4, and DALL-E v3 because images are involved. And here, let's say in our company, we have a blog here. And here we're going to go ahead and pick out, let's say, this post to promote, right? So we're going to just grab this URL, come up here and paste it right here. And now, as soon as I hit this one, it goes ahead and grabs all the data, scrape all the data from the blog post, and it's going to create a summary within 4,000 tokens. I limited it using system prompts, and then we hand over to the post generation. And I'm using Langchain parallel processing, and as you can see, it done it pretty quickly. And they're all copyable with this copy button here. And we can generate images also. So I'm just going to go ahead and first I'm going to go ahead and grab this post, and I'm going to go ahead and generate image, and it's going to start working on it. While it's doing it, it takes a little bit of time. So I'm going to go back and find my Twitter account, and here I'm going to go ahead and straight post this. And as you can see, this is perfectly limited within the 280 characters, including the hashtags and the URL. So with that, now let's go back and see if the image is ready. Yes, it is. So I'm just going to go ahead and download this image. Let's see. Now I'm going to go ahead and look for that image. It's right here. I'm going to upload it and hit the post. And there we go. We have our published Twitter post with image, right? Now let's go back. And here I'm going to grab this guy first, my first Facebook post. And then I'm going to hit generate image. It's going to take its time, and this is going to take it longer because it's going to be wider. 1792 by 1024. So now I'm going to go back and find my Facebook account, and I'm going to create, oh, this is not the create history. I'm going to go post, paste it right here. And here you may need some manual adjustments, like creating some paragraphs, etc. Read our comprehensive, whatever. Give it that, and hashtag, let's say, create some more space. And now that it's ready, we're going to go back and see if our image is ready, and it is. So let's download that image, go back, and try to upload it. And here we go. That's our Facebook image. Open it up and hit next, post. And before you know it, you have a nice little AI-generated Facebook post with image. And now let's go to a diagram where I explain what's happening in the backend. And also, before we go to the diagram, I just wanted to show you another thing is like, since there are multiple posts here, and as you saw, we already posted first two. So whenever we're going to go create our second or third, we just can just hit this generate image again, and it's going to go ahead and create a brand new image. And since our topics are the same, our summarized content is the same, so it's going to generate just a variation of that topic and a different image, just like it's doing it right now. And then you can always go ahead and, let's say, copy this guy and hit this button to download, and see that it's perfectly downloaded, and go on about business, right? So now let's go to the diagram. All right, so this is what's happening behind the scenes for our social media content generator app using GPT-4o and DALL-E v3. So at the beginning, the user is putting in the URL of the post they're trying to promote, and immediately we go all the way to the blog. Our scraping mechanism kicks in and scrapes the data and feeds it to our summarizer module. And the summarizer module then summarizes it using GPT-4o, and I am keeping it within the 4,000 token size. So every time we produce the summary, it will be, the size will be controlled, and that summary then sent to the post generator. And here we are using Langchain's parallel chaining. So pretty much we are dividing two different chains separately, like taking this summary and passing it to a Twitter chain and a Facebook chain. But interesting part is this parallel chaining, which means Langchain is helping us process these two requests parallelly, and thus we're saving a lot of time. It is basically asynchronous. So both happening at the same time, saving us time, and thus we're getting 3 Twitter posts and 3 Facebook posts. And these are the text outputs, right? And copyable. But then right underneath, we're having 2 buttons to generate images. So whenever you need Twitter images, you hit that, and we send that same summary to DALL-E v3. I tried DALL-E v2, but it doesn't take that long of a prompt, but DALL-E 3 can. So here also we send the same summary, but this time we are giving it a different image size. This is like a portrait, and this is like a square box kind of thing. Those are the 2 sizes DALL-E supports. And we're also letting it know that this is a Facebook and this is for Twitter. And then these requests are sent to the DALL-E v3. Thus this module then goes ahead and generates the images for us, and we can just download them and copy our text and go to our corresponding Twitter account or Facebook account and post our social media post promoting the target blog post. So that's pretty much what's going on. And now let's go to the code to have a walkthrough and to get much more details. All right, so we are back at the code. Before I start going through all of them, I first should show you this pyproject.toml. I'm using poetry to organize and deliver my dependencies. And as you can see, these are the dependencies for this project. And here, app.py, that has the UI, UX, and Streamlit code. And this is where I am actually calling all the necessary modules that are under modules. There will be a scrape and summary module, and then post generation module, and an image generator module, and some utility functions. So before I walk you through the app.py, let's go over this modules and utilities first. So, okay, so this one, I'm importing the necessary libraries to create these functions. One would be the download image, and this is what is used to download and save the image locally, as you saw in the front end illustration. And then this is a clean text. This is the one I'm using right after scraping the website data, and I'm cleaning it for like extra spaces, extra new lines, etc., to make the data concise. And this is the calculator, token calculator module, where I am actually sending the content here and using the model.getNum tokens to calculate the number of tokens. That being said, let's look at this scrape summary. All right, so this is the module we're talking about. Once the user pastes their post URL, the one they're trying to promote, this is where we send that URL to. And this guy goes ahead and uses Langchain WebLoader to go ahead and make a request to the blog post, and basically scrapes the data, all the text data, and sends it to our summarizer. Okay, so let's look at this module here. Here are all the necessary libraries, and I'm also bringing in the social media post generator here, which comes from this module. And these are the utility functions, the clean and calculate token size that we just went over. And here are all my environment variables and API keys. I mean, I have plans to, have all these other modules involved also in the future. So I'm just bringing them anyway, getting it ready. And here's the scrape summary generator class, and this is the constructor. That's where we have all our class variables. And this is the load and clean document. Here we are sending the URL and using the web-based loader from Langchain and loading it up on a in the docs variable. And here I am looping through those docs and sending all of them to clean_text utility function that we just went over to clean up the data, get rid of all these spaces and new line characters, etc. And also here from the metadata, we're collecting the source URL and putting it into a variable, and also the title of I'm collecting from those documents. This is basically the title of the blog post, and adding it to a topic variable, and these are the ones we're going to need later on. And once the docs are collected properly, this is a split document method. This is where I'm using recursive characters text splitter from Langchain. Let me just make everything visible like this, okay? And here, this is the total chunk size 2000 by default, and overlap 200. And these are also something that when I call this method, they're flexible. I can just use these numbers to send it here. And this is the final and the main module of the main method of this module, which is the summarize. And this is where I'm first calculating the token size and comparing it with our token limit threshold. And the threshold we're using is 25,000. And mainly because OpenAI has a 30,000 token limit per minute. So I'm just trying to avoid that. And also 25,000 tokens also mean that, let's say 25,000 multiplied by 0.75. That's how we roughly calculate the word numbers, like 18,750 words, which is more than enough for my purposes. So I'm keeping it to this limit. And another reason I'm keeping it to this limit and I'm being hit by a 30,000 per minute threshold is because we are pulling in all the data and sending it to this utility function here, calculate token. And I'm taking a shortcut here. I'm calculating the token by using the model .get num tokens. So that means we are actually sending all the content to a model to calculate the token numbers. That's why I'm being hit by the 30,000. But if you're gonna have to use the larger page content, you can create your own calculator. I just took a shortcut here because I don't really need anything larger than that. But you can create your own token calculator using tick token, and that way you're not going to be hit with this limit, right? All right, so now let's go back. So here, after calculating the token limit, we are making sure that it stays in that limit. Otherwise, we are just telling it, hey, token too large, token number, so do reduce the size, whatever. So but if it is under that 25,000 token, then we're moving ahead and creating a prompt template. This is where I am saying, please summarize the following content, ensuring that the summary is concise and do not exceed token limit. We're giving it a certain token limit not to exceed. And here, as you can see, when I call it, manually setting to 5,000 so that everything is under control and all the summaries are within that limit, right? So that there's no max token problem from the OpenAI models, right? And then here I'm providing the context, and this context is something that we just got through the docs, right? As you can see here, we're creating the summary chain using create stuff document underscore chain from Langchain, sending it our LLM and our prompt. And then self.summary is when we invoke that method, that summary chain. using the context where the docs are that we just collected, and I'm limiting to 5,000. And then the final token size, we're getting the get num token, getting the final number of tokens to make sure, right? And these are the information then I am calling in to this get summary info. This is where I'm collecting all the necessary information for the next module, which is basically going to be our summarizer module right here. And you're collecting the summary, the final token size, the source URL, and the topic, right? And here we have a main function here. I mean, this is something we are not using. I just added this to, when I was adding this module, I just had to test this module individually. So that's why this main was necessary, but this is not being used for the application. All right, so our next stop should be post generator. All right, so this is where we are right now. We scraped it and then summarized it and then send the data over here to our generator module. And this is where we're going to be using something special called Langchain's parallel chaining. And this is where we're going to collect our topic and summary and send it to, we're going to first create two separate chains, two separate engineered prompts, and give them the topic and the summary separately, two separate chains. But then we will have a main parallel chaining, which will actually start these two at the same time, run them at the same time using parallel processing, and that way save us a lot of time, right? So let's go. All right, so this is our post generator. Here I am bringing in all the necessary libraries. Something to notice here, JSON output parser from Langchain, because our outputs, we are making sure they're in a JSON format so that we can display them in whatever way we want. And to support that JSON output parser, we need Pydantic v1 from Langchain core. And to create our parallel chaining, we're going to need runnable parallel and runnable lambda from Langchain schema runnable. And of course, OpenAI, chat OpenAI, and we're bringing in prompt template from Langchain core prompts. That said, and this is the class social media generator, and this is the constructor. That's where we are defining our LLM with GPT-4o. And then remember, we talked about two separate chains here. These two guys, they're right here. Generate Twitter post chain, generate Facebook post chain. They're pretty much identical, except for this part. They have their different instructions according to whatever social media they're targeting. As you can see here, for Twitter, a 280 character limit, including the URL, is mentioned here, and this URL means the blog post URL that we're going to be including, and that could be as long as 100 characters sometimes. So when generating these Twitter posts, our AI has to remember or keep in mind that including that URL, it has to be below 280, and that's why you saw when we copied and pasted our Twitter post, it fit exactly right, not a character more, not a character less, right? So, and then format instructions, that's basically the Pydantic format instruction for the JSON output parser. This is where we are telling the AI how to format the output as a JSON output format, right? And this is where we have the prompt template, the input variables, the partial variables, so with the format instruction, etc. And then using LCEL, which is Langchain expression language, we're creating this Twitter chain, prompt template, LLM, and the JSON parser, right? And here we are declaring the values for the input, which is basically the summary, the string as summary, and then the topic and the URL. And with all that, we are just invoking, we are actually not invoking, but we're returning the invoking process, which is, Twitter chain.invoke and input data. and so that we can use that in our parallel module, right? So exactly the same way, we have our Facebook post generated, everything exactly the same, except this instruction, this prompt engineering here, telling it to exclusively write for Facebook and all the necessary directions here, format instruction, blah, 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 the prompt, creating the prompt template created, and then the chain is built with prompt template, LLM and JSON parser, and the input data mapped. And we are also, again, returning that facebook.chain.invoke with input data. So now let's look at our parallel chaining, how that works. So let's, we already know where we are, so let's make it a little bit larger. So here, this is the fancy part. This is where we are receiving all the summary topic URL, and here we are basically invoking the Twitter chain and the Facebook chain using runnable Lambda and the chains we created. And then we take those two chains and create the parallel chain with runnable parallel. And, these are, we're calling them branches, like a Twitter chain branch and a Facebook branch, so that come output time, we can separate them and, use them in our display. And in here, we are finally invoking that parallel chain so that both chains run in parallel using parallel processing and returns the result. And here also, I had a main function, but this is only for module testing specifically. But, because I had to go step by step after testing everything to implement this. So this is that function, but in here in our app, we're not using it. Okay. That being said, now it's time to check out our image generation. All right, so now we are at this level. Now we have invoked our parallel chains and we got our results, Twitter post and Facebook post. As you remember in our application walkthrough, that these two columns had two buttons, right? Image generator buttons. And if you clicked on them, this is the module that got invoked, and thus the necessary images were generated, right? So let's go check it out. All right, so this is our, this is probably the simplest one, and this is the image generation module. And this is not Langchain. This is, we are using the OpenAI's API directly, because Langchain is not very good at dealing with media. So right here, we just brought in our OpenAI library, and this is our image class, and this is the constructor where we define our client, the OpenAI client, and using that, we go to our method create image. Let's make it larger here. Okay. All right. So in here, we are receiving the prompt string, and then the size. By default, we are using the 1024 by 1024. The quality, I'm hard coding it to standard, because there's other option is HD, which takes way longer, and this is absolutely not necessary for our purposes. And here, this is the function description, and this is pretty much calling the client.image.generate, and this is basically invoking the OpenAI DALL-E API, and the model we're declaring DALL-E E3, prompt, size, and quality that we just brought in, and most importantly, n equals 1. This is mandatory, and make sure that you only put 1 in there, because otherwise it will fail, because DALL-E 3 is not capable of generating multiple images at a time. It must be n1. So once that is generated, we're just returning the image URL. And one thing to remember, that remember what prompt, we were sending just a prompt, right? So now let's go to check out our main file. This is where the UI UX is created, the Trimlit functions. This is the, now that we know all our modules and helper functions, so this is what's building our application front end. I'm bringing in Trimlit and all the necessary modules. and utility functions. And in here, I'm giving it a wide layout, and that way I could accommodate two separate columns for Facebook and Twitter. And this is the title, and this is where all the session variables are declared. And this is our URL input. The user uses this guy right here to input the URL to send it to the scraper. And here is the button, generate social media. Upon that click, we check for the URL. Once we have the URL, we just kick off this spinner. While the spinner is going, we declare this class. We instantiate this class, scrape summary generator, and with a generator object, then we keep calling these methods. We call first the load and clean, as we saw it before, sending the URL, and this is the one bringing in the data and cleaning it, and then document slip, and then the document splitter, split documents, sending these docs, and then summarize function with the split docs, and then remember that summarize info, that's what giving us all the necessary results. And then accordingly, we are populating all our session variables to be used in the Streamlit function, Streamlit front end. Here's a subheader, the summary, and this is where once we grab the summary, we just display that quickly. And then comes the generating the post, because at that point we just hand off, we just basically collect that summary, and we declare this new class called the social media post generator class, and create an object post generator, and using that we invoke that generate social media post, and we send all the necessary data, which is the summary, topic, and URL, to create or launch these parallel chaining, and we receive our output separately, right? And that's what you're seeing right here. So this is the output for the Twitter branch, this is the output for the Facebook branch, and we once again load them up to our session variables. And finally, this is just the front end, column 1, column 2. I have a little CSS to make them look prettier. And right here in column 1, this is where we're displaying the Twitter output. And in here, we have this image generator button. Upon clicking that button, we are invoking that image generator method. Here, and once that button is clicked, we invoke or instantiate that image generator class. Okay, let's make it larger a little bit. Okay, and right. Okay, there you go. So now, once with that image generator object, we just invoke that method, create image, and here we're sending the prompt, generate image suitable for a Twitter post about. And here we are including the topic and the summary. And for Twitter, we are just giving this default size, 1024 by 1024. And once that is achieved, the image is generated, then we generate this button called the download button, download a Twitter image button. And once that button is clicked, we are invoking that utility method called download image. And that one actually grabs the image from OpenAI's Dalle generated image URL to our desktop. It just downloads that image and gets it ready. And exactly the same way, this is the column 2. This is where we're showing the Facebook posts. And I'm using that st.code function. This way, whatever output we get, we have a copy button on the upper right-hand corner, so that I can just one-click copy that social media content, right, and paste it wherever necessary. And just like the other one above, we have an image button, and same way we are instantiating that class to an object, and using that object we are invoking that method, passing the And this time, look, we have a generate image suitable for Facebook. That's the specialized prompt. And but then again, we're sending the same topic, same summary, but another thing different is the image size. To get a rectangular size, we had to take we had to give 792 by 1024 size. Unfortunately, these are the only two types they accept right now in DALL-E v3. So once the image is generated, we are we have this download button, and this downloads the image exactly like before, and as you saw in the application front-end demonstration. And that's where I conclude this video. Thanks for watching.